laws of inheritance or laws of inheritance. Okay. These laws were not actually given by Sir Mendel. These laws were based on his research on a pea plant, right? These laws were given by the three scientists. I told you about these three scientists. So just write in the comment box what are the names of the scientists. Okay. So these three scientists wrote these laws based on the work of Mendel, right? These laws are, the first one is law of dominance. The first one is the law of dominance. Now, what does this law say? There are 3 points in this law. The first one says that the characters are controlled by discrete unit called vectors. So, whatever the characters we inherit or are related from our parents are controlled by the discrete unit called vectors. We have already discussed about vectors. What are vectors? They are the carrier of information from one generation to the next generation, right? We know them today as genes. Now, who gave this term vector? You already know this. Mendel. Mendel gave this term vector, right? Now, who gave this term? Gene. Gene was coined by Johansen, right? So, this term gene, which we know today, was termed by Johansen, and they were originally called vectors. And who gave the name vectors to it? Sir Mendel, right? So, if a question is asked that what is the original name of a gene, then it is vector, right? And vector term was given by Sir Mendel, and gene was coined by Johansen, right? So, the first point is that the characters are controlled by the discrete units, the unit that are discrete, and these are vectors, right? The second point is these vectors occur in pair. Now, the second point is vectors occur in pair. These vectors occur in pair. So, you guys would be thinking, are they afraid of something? Why they occur in pair? Why they come together? Well, they're not afraid of anything. Actually, the offspring receive one gamete from the male and the second from the female. So, when it fuses, when the male and the female gamete fuses, it becomes a pair, right? So, why they occur in pair? You have got to know about. And in the gamete formation, they segregate again, right? They will become one, and but when this will fuse with another gamete, it will become a pair again, and when this will fuse with another gamete, it will become a pair again. Okay, so these vectors occur in pair. Now, the third point is, well, the first point was the characters are determined by vectors, and the second is the vectors occur in pair. Now, the third point says that in a dissimilar pair of vector, one is dominant and one is dominant and the other is recessive. Okay. Now, when the vectors are dissimilar, so one will be dominant and another will be recessive. If I talk about this pair of vector, it is a similar one will be dominant in this pair and the other will be recessive, right? So this was according to the law of dominance. Now the second law. Now what is the second law of Mendel? The second law of Mendel is the law of segregation, right? The law of segregation, and we also call it the law of purity of gametes. This is the second law of Mendel, right? The law is the law of segregation and the law of purity of gametes. Now what does it state? It states that the two alleles received one from each parent segregate independently of each other in a gamete formation, so that one gamete receives one or the other with equal probability. Okay, so in this pair, this and this will segregate. Now what does the meaning of segregate mean? Segregate, it means separate. It means that they both will separate from each other independently of each other in the gamete formation. When the gamete will form, the half of the gametes will receive this and half of the gametes will receive this. Okay, so in the gamete, half of the gametes will be this and half of the gametes will be this. So these are the law of segregation. They segregate independently of each other. Now it will be better understood if we understand a monohybrid cross. We have talked a little bit about monohybrid cross. Now let's understand it completely. What is a monohybrid cross? As I've already told you that mono, it means one, right? And hybrid refer to the offspring, that is the result of two dissimilar parents, right? And when we are talking of a single character, then it is a monohybrid cross. Now let's take an example. When we are talking of a height of stem, right? We are taking an example of the height of the stem. So the alleles, we will cross with a pure line first. Okay, we have taken a pure line. Pure line means what? It means that this is similar to this, right? That the alleles are similar to each other and it is completely tall, right? So this is a tall plant having a homozygous pair of alleles, and it is crossed with a dwarf plant having a homozygous pair of alleles again. Okay, so this is crossed with this. Actually, what Mendel saw that the plants were tall and some of the plants were dwarf, or we can say short. So he crossed these plants, right? So what he saw in the first generation, when this gamete, it will form two gametes, right? And it will also form two gametes, right? Two different types of gametes. It can fuse with this, right? Let's make a Punnett square. Now let us suppose that this is a female, you could say, and this is a male, right? Let's suppose that this is a female and this is a male. So let's write female here and male here. Okay, so this and this. When this gamete will fuse with this gamete, it will produce will fuse with this gamete, it will produce this. Okay, and when this gamete will fuse with this gamete, it will form this, and similarly when this will fuse with this, it will form this. So all the plants in the F1 generation, these are the parents, right? These are the parents, and this is the first generation. We also call it filial generation or the F1 generation, right? Filial can be F1, F2, F3, right? So F1 generation will have all the plants that are tall. Why tall? They were crossed with a tall and a dwarf plant. But Mendel saw that all the plants were tall. So he concluded that. So what Mendel concluded? That all the plants were tall, so this character of the tall plant is dominant over this. Okay, this is a dominant character and this is a recessive character. Fine. So this dominant character and this recessive character, when they both appear together, this dominant will mask this. Mask it means it will hide this. Okay, so it will appear in the first generation. Now what will happen in the second generation? Mendel wanted to see, so he did the selfing. Now what is selfing? I already told you. Selfing, it means crossing the plants or breeding the plants of the same types, of the same generation, we can say. So he crossed this with this, right? So let's take it as female and this as male. B, T, T and T, T. So in this generation, when this gamete will fuse with this gamete, it will be this, and this gamete will fuse with this gamete, it will produce this. When this gamete will fuse with this gamete, it will be this. We will write the dominant first and the recessive later. Okay, so when this will fuse with this, it will give this offspring. When this will fuse with this, it will form, right? So what we are seeing now, this and this, these both are homozygous, but this one is dominant and this one is recessive. Okay, now in this one, these both are what? These both are tall but heterozygous. Heterozygous means they are having a dissimilar pair. Okay, so what is the phenotype of the plants? The three plants are tall, so 3 tall is to 1 dwarf. The phenotype, I have already told you that the phenotype is the physical appearance of the plant. So the phenotype will come out to be 3 tall plants. We don't know what the alleles are, but we can see that the plants are tall. When we do it practically, we are doing it theoretically, so we can see that these are the alleles, but when we will perform it practically, what we will see that 3 are tall and 1 is dwarf. Now the next thing is the genotype. The genotype in this case will be this will be a homozygous tall is to this will be a heterozygous tall and this will be a homozygous dwarf. So this is tall and this is 1 is to this is heterozygous tall. These are 2 and this is 1. So phenotype ratio is 3:1 and genotype ratio is 1:2:1. Okay, so now in the F1 generation, what we saw that all the plants were tall. So the phenotype in the F1 generation was uh, 4:0, right? As well as the genotype is also same in all the plants, so it is also 4:0. So this is about a F1 generation, and if we talk about F2 generation, then we have discussed already that the phenotype will be 3:1 and the genotype will be 1:2:1, right? This was about a monohybrid. Okay, now let's talk about a dihybrid cross. Now what is a dihybrid cross? If we are talking of a dihybrid cross, it means that we are talking of two characters at one time. Actually, Mendel wanted to see that either the two characters are linked to each other or not. So he performed a dihybrid cross. So let's take an example of the seed. The shape of the seed is round and the color is yellow in the dominant case. And in the recessive case, the shape of the seed is wrinkled and the color is green, but we will write it with the same letters in the lower case. Okay, so when we will cross this with this, right, we are taking the characters, the color and the shape of the seed. Then we will cross with this. What is found in the F1 generation? These are the parents, and this is the offspring of the F1 generation. Now this can go with this, and this can go with this, or this can also go with this, and this can also go with this. So there are 4 gametes. How these are, this will link with this, and this can also link with this, and now this can link with this and also with this. So according to this, these are 4 types of gametes in the dominant case. Now if I talk about a recessive case, it can link with this and also this, and it can link with this and also this. So again we are having 4 types of gametes in the recessive case. So when they will fuse with them, what will happen? We will again draw a Punnett square. Why we have written these 4 times? Because there are 4 types of gamete produced. So suppose this is a female and this is a male, and we will cross it with this. Okay, so the offspring will be, this will fuse with this and with this. The offspring formed will be this in all the cases, right? Because gametes are same in all the cases. So in the F1 generation, all the 16 offsprings will be of brown shape and yellow color, right? So the phenotype is 16:0 and genotype is also 16:0. So in the F1 generation, phenotype and genotype both are 16:0, right? Now, next, when this was crossed with this, it means we have done the selfing. When we are crossing the individuals of the same generation, right? So, the gametes produced will be, it can go with this and it can also go with this. It can go with this and also with this. So, the gametes produced will be R, Y, R, Y. We can write like this. Okay? Then R, Y and R, Y. Same in the case of this. These are the gametes produced. They are independent of each other, right? So they are not linked to each other. They are independent of each other. So what offsprings will be there in the F2 generation? We will again draw a Punnett square. Let's take a female and this a male. And it will be RY, RY, R capital Y and R small y. Again, this and this and this and this. So, when this will fuse with this gamete, what will be produced? This is the offspring produced when this gamete will fuse with this gamete. Now, when this gamete will fuse with this gamete, what will happen? This will form, right? So, when this gamete will fuse with this is capital Y, this is small r and both are capital Y, okay? Then, right, now in the next one, this and this will fuse and it will form this. In this case, both are capital R and both are small y. In the next case, capital R, small r, capital Y, small y, right? Then, in the next one, capital R, small r, and both are small y, right? And in the next one, it will be capital R, small r, and both are capital Y. Then again, R, Y, right? So, this is both are small r and both are capital Y. In this will be both are small r, one is capital and one is a small y. Then it will fuse with this to form, this is a capital R, this is a small r, this is a capital Y and this is a small y. We will always write the dominant character or the capital letter first, and after that we will write the recessive character or the lowercase or the small letter, right? Now this capital R, small r and both are small y. This is both are small r and one is capital Y, one is a small y. Now only in this case, this is what you know this is homozygous, right? So in this case, this is homozygous and this is So homozygous. This is a round seed with a yellow color, right? And this is a wrinkled seed with green color, right? So these are the offsprings in the F2 generation, right? So what we have seen in this, that they are independent of each other. So what this law, the third law of independent assortment, what does it state? It states that the two characters determined by the two unlinked genes. So the genes are unlinked. The genes are not linked to each other, right? So the two characters determined by two unlinked genes are recombined at random in gamete formation so that they segregate independently of each other, right? Each according to the first law. So this is what the law of independent assortment say, that this and this are independent of each other. This can go with this and this can also go with this. They are not dependent on each other, they are actually independent of each other. So this was the law of independent assortment. Is it clear to you all? Ratios in the F2 generation in a dihybrid cross. In a dihybrid cross, the ratio in the F2 generation will come out to be 9:3:3:1. Out of 16 plants in the F2 generation, 9 were round and yellow. 3 were round and green. 3 were wrinkled and yellow. And only 1 out of 16 plants was wrinkled and green. This is a phenotypic ratio, right? Genotypic ratio is not much important in this case, but if you want to write, you can write as this is to this is 2, and there are so many, you can write them, but this is important in this case. The phenotypic ratio comes up to be 9:3:3:1. 9 are the dominant characters together, round and yellow. In these 3, 1 is dominant and 1 is recessive. And in the one plant, it was a recessive character that was shown. So this is the ratio in the F2 generation of a dihybrid cross. So we will discuss the next topics in complete dominance and codominance in the next video. And if you like my video, please click on thumbs up and subscribe to my channel. And if you have any query related to these topics, you can write in the comment section. Thank you so much.